All right, so we're diving into this Rhymes AI paper today.
Okay.
And it's all about their new text-to-video model, Allegro.
Right.
And
Yeah.
it's getting a lot of
It
buzz
is.
because it seems like it can generate some pretty commercially viable video,
Mm-hmm.
like almost Hollywood-level stuff,
Yeah.
just from text prompts. And, I'd love to get into the technical details.
Yeah.
I'm really excited to hear what you think about this.
Well, what's really interesting about Allegro is that it's addressing like a real gap
Right.
in the AI world because we've seen just this explosion of all these
Yeah.
open source tools for image generation.
Mhm.
But when it comes to video,
Yeah.
high quality video generation has really lagged behind.
Yeah, and from what I've read, it seems like Allegro is kind of changing the game
Yeah.
with this focus on temporal consistency.
Right.
Um, I understand that that means that like the motion in the videos is really smooth
Yes.
and it looks realistic.
Yeah.
But can you break down why that's so hard to achieve and how Allegro actually tackles it?
Sure. So it all comes down to the complexity of video data because unlike a single image,
Right.
a video is a sequence of frames,
Mm-hmm.
each one slightly different from the one before it. So, to generate that realistic motion, the AI has to understand not just what each frame should look like,
Yeah.
but how those frames flow together over time.
Right.
So it's not just about like a single image, it's about this whole sequence
Yeah.
and how it all fits together. And that's a real challenge.
Mm-hmm.
But Allegro addresses this with this really clever combination of some powerful neural networks and some really smart training techniques.
Got it. The paper also mentioned that they trained Allegro on this
Oh,
absolutely massive data set
huge.
of images and videos. I think it was over 100 million images.
Yeah, over 100 million images.
And it's something like almost 50 million videos.
Yeah, 48 million.
So it's not just about quantity, is it?
No, not at all.
Like, how do they make sure the quality is there too?
The quality and the curation of the training data are absolutely crucial.
Okay.
You can think about it like teaching a child to paint.
Okay.
If you only show them blurry, poorly composed pictures,
Yeah.
they're not going to develop a good eye for art.
Right.
The same principle applies to AI.
Mm.
Allegro was trained on a meticulously curated data set.
Okay.
So it's learning from the best possible example.
I see. So it's like they're giving it a really strong foundation to build on
Exactly.
from the start.
Yeah, giving it that good taste,
Right, right. And they use this technique
Yeah.
called CLA similarity filtering
Mm-hmm.
to make sure that the text descriptions and the visuals are really tightly linked.
Right.
I have to admit, I'm not super familiar with CLIP. Can you kind of walk me through that?
Sure, yeah.
And I think maybe some of our listeners
Yeah.
who are really deep in the AI world
Hmm.
might appreciate a little refresher too.
Absolutely. So CLIP is a separate AI model that is really good at understanding the relationship between images and text.
Okay.
So it can analyze an image
Yeah.
and create this numerical fingerprint that kind of captures the essence of that image.
Okay.
And it can do the same thing with the text description.
Gotcha.
So by comparing these fingerprints,
Yeah.
CLIP can tell how well the image and the text actually match up.
So it's like a matchmaking service for
Sure.
images and text.
A matchmaking service for images and text. That's a great way to put it.
Yeah.
And so during Allegro's training, they use CLIP to filter out any data where the image and the text descriptions didn't align well.
Oh, so it's like a quality control step.
Exactly, a quality control step to make sure that Allegro is only learning
Okay.
from examples where the visuals and the text are really congruent.
So that makes a lot of sense.
Yeah.
It's like they're teaching Allegro to speak the language of visuals fluently.
Exactly.
So there's no more like awkward AI generated videos
Right.
where the visuals are totally off from the text prompt.
Exactly. It's all about getting that connection, right?
Yeah.
And so this meticulous approach to data curation is one of the key factors
Okay.
that sets Allegro apart.
Mm-hmm.
It's why it's able to generate videos that are not only visually stunning,
Right.
but also deeply relevant to the text prompts.
That's great. Another thing that I thought was really interesting in the paper
Yeah,
was this two-stage training process.
right?
It seems like they took a really deliberate approach
Yes, they did.
to training Allegro.
So instead of just throwing Allegro straight into the deep end of video generation,
Okay.
they first focused on making sure it could nail still images.
So it started with the basics.
Start with the basics, get that foundation right.
Yeah.
This allowed the model to develop a strong understanding of visual composition,
Mm.
lighting, and those other essential elements.
Okay.
And once it excelled at still images,
Yeah.
then they gradually introduced the motion,
Okay.
increasing the resolution and number of frames that Allegro could handle.
So it's like a step-by-step process.
Step by step, build up that complexity over time.
Yeah. And I guess that probably makes a big difference.
Yeah.
In the quality of the final output.
Right, because it's not overwhelming the model.
Yeah.
With too much information all at once. It's
Right.
giving it time to learn and to master each stage before moving on to the next.
That makes a lot of sense. And speaking of like a lot of information,
Yeah.
video files are huge.
Hugo.
So I'm curious,
Yeah.
how did they handle the sheer size of the data during training?
That's where a crucial component called video VAE comes in,
Okay.
which stands for Video Variational Auto-Encoder.
Video VAE.
Yeah.
Okay, break that down for me. I
Yeah.
think some of our listeners might not be
Yeah.
as familiar with these concepts as
Sure.
maybe we are.
So think of video VAE as a super efficient compression algorithm,
Okay.
specifically designed for video data.
Okay.
It essentially learns to represent the complex visual information in a video
Right.
using a much smaller set of numbers.
So it's basically shrinking down those files
Yeah, it's shrinking it down without losing that essential information.
without losing any of the important stuff.
Exactly.
So is that like,
Yeah.
does that impact the quality of the output at all?
That's a great question, and the researchers actually spent a lot of time
Okay.
optimizing video VAE to make sure that the compression process
Yeah.
doesn't degrade the visual quality of the final output.
Got it.
They found this sweet spot where they could significantly reduce the file size
Okay.
without sacrificing fidelity.
That's impressive.
Yeah, so they're getting the best of both worlds,
Yeah.
smaller file sizes, but still maintaining that high visual quality.
So we have this compressed visual data,
Yes,
and we have the text prompt that you type in.
right.
Walk me through what happens next.
Okay.
Like, how does Allegro actually weave those two things together
Yeah.
to create a video?
So that's where the brains of the operation come in.
Okay.
This powerful component called video DIT.
Video DIT.
Okay. Short for Video Diffusion Transformer.
And that's basically like...
Yeah, it's a type of neural network that's specifically designed
Okay.
to handle the complexities of video data.
So it can.
It takes that compressed visual information from video VAE
Okay.
and the text prompt as input,
Mm-hmm.
and then through a series of really complex computations, it generates a sequence of frames
Okay.
that form the final video.
So it's like stitching together
Yes.
all of these...
It's stitching it all together based on what it's learned.
Yeah, based on the text prompt and
Yeah,
the visual data.
exactly.
So it sounds like Video DIT is doing some serious heavy lifting here.
It is.
Can you tell us a little bit more about how it works?
Sure. So at its core, video DIT is built on these things called diffusion transformer blocks.
Okay.
And these are specialized modules within the neural network
Mm-hmm.
that are designed to model both the spatial and temporal dependencies.
Hold on, spatial and temporal.
Yeah.
Can you explain what those mean
This is
in the
good.
context of video?
Yeah, so spatial dependencies refer to how things are arranged within a single frame. Okay.
Of a video. So, for example, the relationship between a cat sitting on a table
Right.
and the vase next to it.
Okay.
That's a spatial relationship. Temporal dependencies.
Yeah.
On the other hand, capture how things change over time.
Got it.
So like the cat jumping off the table and knocking over the vase.
So one is like a snapshot.
Yeah.
And one is like the whole movie.
Exactly.
Yeah.
So it's understanding both the arrangement of things
Right.
and how they move and change.
Got it.
So video DIT is learning to see the video world in both space and time.
Okay. And are there
Yeah.
are there other modules within those blocks or?
Yes. So within each of those diffusion transformer blocks, there's even more specialized modules.
Okay.
There's a self-attention module.
Self-attention.
Yeah. And that helps video DIT understand the relationships
Okay.
between different parts of the video,
Uh-huh.
both within a single frame
Okay.
and across multiple frames.
So it's like constantly analyzing,
It's constantly analyzing,
figuring out
figuring out what's what's important and how it all relates.
how it all relates. Yeah, exactly.
Okay.
And then there's also a cross-attention module.
Cross attention.
Yeah, and that one's responsible for integrating the text input into the video generation process. So this module helps ensure that the generated video is relevant to the text prompt.
So it's making sure that what you typed in
Yes.
is actually reflected in the video.
Exactly. It's bridging that gap between the text and the visuals.
Yeah, it's fascinating how all these different components work together
It is.
to create a video from just a few words.
Yeah. It's really remarkable.
And there's one more key ingredient in Allegro's text-to-video magic.
Okay.
The text encoder.
Yes, the text encoder.
Okay, so what's that all about?
The text encoder is responsible for taking your text prompt and converting it into a format that video DT can actually understand.
So it's translating it into...
Exactly. Translating it into the language of AI, because AI models don't process raw text directly. They need to convert it into a numerical representation, a sort of mathematical fingerprint of the text.
Okay, so Allegro uses a particular text encoder.
It does.
Called T5.
Right.
Text Transformer.
That's a mouthful, but it's a very powerful model.
And why is that so important for video generation?
Well, think about the subtle nuances of language.
Okay.
If you ask for a video of a cat napping in a sunbeam, you're not just conveying those basic objects, the cat and the sunbeam.
Right.
You're also implying a sense of peace, warmth, and tranquility.
You're painting a picture with words?
Exactly, you're painting a picture with words.
Yeah.
And T5 allows Allegro to pick up on those subtle cues, those underlying emotions and intentions behind your words.
So it's getting at the mood.
The mood, the feeling, the overall vibe.
Yeah.
And this leads to more relevant and expressive videos that truly capture the essence of your prompt.
Okay.
So it's not just about the literal objects. It's about conveying that deeper meaning.
The feeling.
The feeling, exactly.
So T5 is giving Allegro this deeper understanding of human language, allowing it to translate our creative visions into these really compelling visuals.
Exactly. And it's one of the key reasons why Allegro is able to generate videos that feel so human, so emotionally resonant.
That makes sense. This is all incredibly impressive.
Yes.
But it also sounds incredibly complex.
It can be.
So is this is Allegro only for AI experts?
That's a great question. And actually, one of the most exciting things about Allegro is that it's designed to be user-friendly.
Okay.
You don't need to be a coding whiz or an AI guru to use it.
So
Rhymes AI has created some very intuitive interfaces that allow anyone to just type in a text prompt and watch the magic happen.
So you're telling me I could literally type in a robot dog doing backflips on Mars.
Yeah.
And Allegro could generate a video of that.
That's the idea. Of course, the quality of the output will depend on the clarity and specificity of your prompt.
Right.
But Allegro is surprisingly adept at handling even creative and imaginative requests.
That's amazing. It feels like we're really on the verge.
I think so, too.
Of like a whole new era of content creation where anyone can bring their ideas to life through video, regardless of their technical skills.
Yeah, I think that's one of the most exciting aspects of this technology, is that it's really democratizing video creation.
Right.
It's making it accessible to everyone.
You don't need a fancy studio.
You don't need a fancy studio.
Or expensive software anymore.
No.
Just a few well-crafted sentences.
Yeah.
And the power of AI.
And some creativity.
It's mind-blowing.
It is.
And to make things even more accessible, Rhymes AI has released Allegro under the Apache 2.0 license.
Yes, they have.
Wait, so you're telling me this incredibly powerful AI model is open source?
It's open source.
Anyone can use it for free.
Anyone can use it for free.
This is huge.
It's a game changer.
Rhymes AI's decision to open source Allegro is, it's a game changer.
It really is.
It means that researchers, developers, even just hobbyists can experiment with this model, contribute to its development, and really explore its potential in a wide range of applications.
Yeah, they've removed the barriers to entry.
It's amazing.
And I think that's going to lead to a lot of really interesting and creative uses of this technology.
Yeah, open sourcing Allegro is going to democratize access to this high-quality video generation.
Absolutely.
And I think it's going to foster this whole wave of innovation and creativity.
I agree. It's really exciting to think about all the amazing things people are going to create with this technology.
But before we get carried away with future possibilities, let's take a step back and look at how Allegro actually performs.
Okay.
Rhymes AI conducted a pretty thorough evaluation of the model.
They did.
Comparing it to other leading AI video generators, and I think you're going to be impressed by the results.
I think so, too.
So let's dive into those results.
Let's do it. So to really understand how Allegro stacks up rhymes, AI used both quantitative and qualitative measures.
Okay.
They conducted a user study to get feedback from actual humans.
Yeah.
And they ran it through a benchmark specifically designed to evaluate AI video generation models called VBench.
Okay, it's great that they included that human feedback.
Yeah.
Because numbers can only tell you so much.
Exactly.
What kind of things were they looking at in that user study?
So they focused on 6 key areas.
Okay.
Video text relevance, appearance, distortion, appearance, aesthetics, motion things, naturalness, motion amplitude, and overall quality.
Wow, that's a lot.
Yeah. Essentially, they were trying to see how well the generated videos matched the text prompts, how visually appealing they were, and how realistic the motion was.
So it sounds like they really covered all the bases there.
Yeah, they wanted to get a comprehensive view of the performance.
And I'm guessing Allegro aced that video text relevance category.
Yeah.
Given how much emphasis they put on linking the visuals and text during training.
You nailed it. Allegro actually beat all the commercial models in that category.
Wow.
Which really highlights the power of that CLIP filtering technique we talked about.
That's impressive. So it really understands what you mean.
Yeah, it's not just generating random visuals.
Yeah.
It's really trying to capture the essence of the text.
But what about the actual look of the videos? Were they visually appealing?
Yeah.
And did the motion look natural?
Allegro did incredibly well there, too. It scored higher than all the open source models.
Okay.
And most of the commercial ones across those visual categories.
Wow.
So people were really impressed with the quality and realism of the videos.
Okay, so we've established that Allegro is good.
Yes.
Really good. But it's not perfect, is it?
Right.
The paper did mention some limitations.
That's right. No model is perfect, and one area where Allegro still has some room for improvement is in handling large-scale motion. It tends to do better with scenes that are relatively static or involve subtle movements.
So like close-ups?
Yeah, or maybe like a conversation between 2 people.
Okay.
But it might struggle with the scene of a flock of birds taking flight.
Right, lots of movement.
Yeah, or a really fast-paced car chase.
I can see how those types of scenes would be more challenging to generate.
Definitely more complex.
But I'm guessing that's something that could be improved with more data?
Exactly. Yeah. The researchers believe that feeding Allegro more examples of videos with that dynamic large-scale motion would help it learn to generate those types of scenes more effectively. So it's all about exposure and learning from diverse examples.
The more it sees, the more it learns.
That's the idea.
But even with those limitations, this feels like a huge leap forward.
Yeah, it really is.
What are some of the real-world applications for this kind of technology?
Oh, the possibilities are vast. Imagine easily creating videos for marketing materials, presentations, educational content, even social media posts, all from a simple text prompt.
So you could create a whole ad campaign just from a few sentences.
That's the idea. It could revolutionize the way we create and consume video content.
It's like democratizing video creation.
Exactly.
You don't need a fancy studio or expensive software anymore.
Nope.
Just a few well-crafted sentences and the power of AI.
That's all you need.
It's mind-blowing.
It is pretty amazing.
And think about the implications for accessibility.
Yeah.
People with disabilities who might find traditional video editing tools challenging could use Allegro to bring their creative visions to life.
Absolutely. It could empower people to tell their stories in new and innovative ways.
That's a really important point.
Yeah.
It's exciting to think about how this technology can level the playing field and give everyone a voice.
Yeah, it's breaking down those barriers.
The paper also mentions some interesting future directions for Allegro.
Yeah.
Can you give us a sneak peek?
Sure. So they're exploring some really cool ideas. One is adding the ability to generate videos based not just on text, but also on images.
So you could give it a starting image.
Exactly.
And then it would build on that.
Yeah. So you could give Allegro a starting image and a text prompt. And it would create a video that seamlessly extends that visual.
Oh.
Imagine taking a still photo and then animating it with AI.
That's next level.
The possibilities are endless.
What else are they working on?
They're also working on giving users more control over the motion in the videos. For example, you might be able to specify that you want a specific object to move in a certain way.
So you could really fine-tune it.
Yeah, or you could control the camera angles and movements.
Wow.
So it's about giving creators the tools to really fine-tune their vision and shape the narrative.
So it's not just about generating a video.
No.
It's about giving users the tools to direct the creative process.
Exactly. It's about empowering creators, not replacing them. AI is a tool, and Allegro is a particularly versatile one.
Yeah.
But before we wrap up this deep dive on Allegro, there's one crucial piece of the puzzle we need to discuss.
Well, what's that?
We need to take a closer look at the technical architecture of Allegro.
Okay.
It's not just a black box. The researchers were very transparent about the specific architectural choices they made.
Good.
And those choices played a key role in Allegro's success.
Okay, you've piqued my curiosity. Let's lift the hood and see what's powering this amazing AI.
Oh, let's do it.
Okay, let's get technical.
All right.
We've talked about the impressive results that Allegro is achieving, all these exciting potential applications. But now I'm really curious to understand how it all works under the hood.
Okay.
The paper mentions some pretty advanced architectural choices that contributed to Allegro's success.
Right.
Can you walk us through those?
Absolutely. So remember how we talked about video DT, the brains of the operation?
Yeah.
Well, the researchers made some really clever design decisions within video DT's architecture that significantly boosted its performance.
Okay, remind me, what's video DT again?
So video DT, short for Video Diffusion Transformer,
Right.
is that core component that's responsible for generating the video frames.
Okay.
It's a type of neural network specifically designed for video data, and it's built upon these modules called Diffusion Transformer blocks.
Right. Those blocks are responsible for understanding both the spatial and temporal relationships in the video.
Yes.
Like how things are arranged within a frame
Yeah.
and how they move over time.
Exactly.
Yeah.
Now, within each of those diffusion transformer blocks,
Yeah.
the researchers incorporated some specialized mechanisms that really make a difference.
Okay.
One of the key innovations is the use of hierarchical spatial attention.
Hierarchical spatial attention.
Yes.
I'm intrigued, but also a little lost.
Okay.
Break it down for me.
So think of it like this when we look at a scene.
Okay.
We don't process every single detail with the same level of attention. We focus on the most important elements first.
Like the people.
Yeah, like the people or objects in the foreground.
Okay.
And then our attention might shift to the background or smaller details.
So we're prioritizing what we focus on based on what's most relevant to the scene.
Exactly. And that's what hierarchical spatial attention allows video DT to do.
Okay.
Instead of treating every single pixel in the frame equally, it learns to prioritize different areas based on their importance. This allows the model to process information more efficiently.
So it's not wasting time on things that aren't important.
And it can focus its computational power where it matters most.
That's really clever. It's like giving video DT a human-like ability.
Yeah.
To understand what's visually important in a scene.
Exactly. It's mimicking that human visual system.
And is there anything else that it does to kind of...
So there's another cool trick up video DT's sleeve.
Okay.
Temporal aware dynamic convolutions.
Okay, that one definitely sounds intimidating.
Right.
What are dynamic convolutions and how are they temporal aware?
So don't worry, the concept is actually simpler than it sounds.
Okay.
Convolutions are a fundamental operation in image and video processing.
Okay.
They essentially involve sliding a small filter across the image or video, extracting features from the pixels.
So it's like running a magnifying glass over the video.
Yeah, that's a good analogy.
Looking for patterns and details.
Exactly, looking for those patterns and details.
Okay.
Now, traditionally, those convolutional filters are fixed. They have the same weights and operate the same way regardless of what's happening in the video.
Right.
But in Allegro, they made those filters dynamic.
Dynamic meaning they can change.
Exactly. They can adapt and adjust based on the specific content of the video.
Got it.
And the temporal aware part means that the filters also take into account the temporal information.
Okay.
The changes that are happening over time.
So it's not just looking at a single frame.
No, it's looking at the whole sequence.
It's looking at how things are moving.
Exactly, and this allows video DT to capture more nuanced and subtle motion patterns.
So it's like those filters are becoming more intelligent.
Yes.
Adapting to the specific needs of each video sequence.
Precisely, and it's one of the key reasons why Allegro is able to generate such smooth and realistic motion.
But all this computational magic comes at a cost.
It does.
Processing power.
Yes. Processing power is a big consideration here.
Yeah, we've talked about the sheer size of video data, the complexity of these models.
Right.
It must take a ton of computing power to train Allegro.
You're absolutely right. Training these models can be incredibly demanding on hardware.
Okay.
But the Rhymes AI team came up with some clever optimization techniques to make the process more efficient.
Tell me more about these optimizations.
Okay.
I'm always fascinated by the engineering ingenuity that goes into making these AI models work.
Absolutely. So one of the key techniques they used is called decoupled inference of VAE.
Okay.
Which, as you may recall, refers to the video variational autoencoder.
Right. That component responsible for compressing the video data.
The shrinking ray.
Exactly, the shrinking ray.
Okay.
Now, traditionally, the encoding and decoding process of VAE is tightly integrated with the main training process.
Okay.
But the researchers found that this could create bottlenecks, slowing down the training.
So they had to find a way to speed it up.
Exactly. So they decoupled those operations, allowing them to run independently on separate GPUs.
So it's like they created a parallel processing pipeline. Absolutely. It's not just about the theory, it's about the practical implementation as well.
Right.
And they didn't stop there. They employed several other optimization techniques.
Oh, wow.
Like using specialized attention mechanisms to make the computations more efficient.
Okay.
And leveraging something called context parallelism.
Context parallelism.
Yeah. This involves splitting the video data into smaller chunks.
Okay.
And processing those chunks in parallel across multiple GPUs.
So it's like they created an AI assembly line.
I love that analogy.
Where each GPU has a specialized task.
Yes.
And they all work together to build the final video.
It perfectly captures the collaborative nature of these distributed training approaches.
Yeah.
And it's a testament to the ingenuity of the researchers and engineers who are pushing the boundaries of what's possible with AI.
Absolutely.
Yeah.
So where do we go from here?
That's the big question, isn't it?
Yeah. What's next for Allegro?
Right.
And for the field of AI video generation in general?
I think we're just scratching the surface of what's possible. As these models get better at understanding the nuances of language and the complexities of visual motion, we can expect to see even more realistic, creative, and compelling videos.
It's both exciting and a little mind-boggling to think about the potential implications.
I know, right?
We could see a future where AI-generated videos are indistinguishable from those created by humans.
It's a crazy thought.
Even surpassing human capabilities in some areas.
It's possible.
That's amazing.
It's a fascinating and potentially disruptive prospect.
Yeah.
But I believe that AI video generation tools will ultimately augment human creativity, not replace it.
Okay.
They'll free up creators to focus on the higher level aspects of storytelling while the AI handles the technical heavy lifting.
It's like having an AI co-pilot.
Exactly, an AI co-pilot for your creative journey.
On your creative journey.
And who knows what incredible stories we'll be able to tell with these new tools at our disposal.
I, for one, am incredibly excited to see what the future holds.
Me too.
For AI video generation and how Allegro will continue to evolve.
It's going to be an interesting ride.
Thanks for taking us on this deep dive.
My pleasure.
It's been an enlightened journey.
I'm glad you enjoyed it.
And that wraps up our deep dive into Allegro. We hope you enjoyed this exploration into the fascinating world of text-to-video AI. Until next time, keep exploring, keep learning, and keep creating.